Okay, I just wanted to do another quick tutorial on applying the standard normal distribution. Um, so I'm going to go through this one quite a bit quicker than I did on the previous lesson. So just very quickly, once again, here's the graph of normal distribution. Key things you need to remember: 68% of the data is within one standard deviation of the mean, 95% of the data is within two standard deviations of the mean, and 99.7% of the data is within three standard deviations of the mean. And make sure to remember the mean is right here in the middle. Okay. Um, so we're going to do pretty much one example with a bunch of different parts. So here's our set of data that we're going to use for each part. Height of cacti are normally distributed with a mean of 1.4 and a standard deviation of 0.3, sorry. So what it's told us here is actually quite a bit. It's told us that it's normally distributed. So how I write this is, I write the data forms a normal distribution that has a mean of 1.4 and a standard deviation of 0.3. And it's standard to write the standard deviation squared when we're writing it in the normal distribution notation. So this is going to be our set of data for all of the questions. Normal distribution with a mean of 1.4, standard deviation of 0.3. So keeping that in mind, 68% of the cacti would be between which two heights? So to do that, you'll have to remember back to our original diagram here, 68% of the data normal distribution will be within one standard deviation of the data set. So our mean was 1.4, so our mean is right in the middle, and our standard deviation was 0.3, so it goes up by 0.3s and down by 0.3s this way. 68% of the data is going to be within one standard deviation of the mean, so it's going to be between 1.1 and 1.7. 68% of the cacti, or the area between one standard deviation less than the mean, one standard deviation more than the mean, the area would be 0.68, which tells us 68% of the cacti would have a height between 1.1 meters and 1.7 meters. And here's the calculation doing it mathematically instead of using the diagram. We know 68% of the cacti are going to be within plus or minus one standard deviation from the mean, so that's between 1.1 and 1.7. And here's the calculation right here, showing us subtracting 0.3 and adding 0.3 from our mean to get those boundaries. Okay. Maybe I should show you a calculator as well. Oh, it's okay. I'll do that later. Okay. Number 2, what percent of cacti are between 0.8 and 2 meters tall? So once again, here's my normal distribution. The average cactus height was 1.4 with a standard deviation of 0.3. So I'll just quickly label this. Okay, yep, so don't forget our normal distribution, mean of 1.4, standard deviation of 0.3. Now, I want to figure out what percent are between 0.8 and 2. So 0.8 is here, 2 is here. You'll notice that 0.8 is 2 standard deviations less than the mean, and 2 is 2 standard deviations more than the mean. And if you remember back to our diagram from the beginning, 95% of the data in a data set that is normally distributed will be within 2 standard deviations of the mean. So once again, 95% of the data is within 2 standard deviations of the mean. 0.8 is 2 standard deviations less, 2 is 2 standard deviations more. Therefore, 95% of the cacti would have a height between 0.8 and 2 meters. If you wanted to use your calculator to check this instead of using the graph, we would just use the function normalcdf. You then tell your calculator your left and right boundary, so 0.8 and 2. Okay, those are our boundaries. Here is 0.8, here is 2, and we want the area between those two. We then also have to tell the calculator the mean and the standard deviation of the data set, 1.4 and 0.3. I think it was 1.4 or 0.3. Is that right? Yep. So we can do that function on the calculator. Just clear this here. So you would do second vars, go down to normal CDF, type in your left boundary, comma, the right boundary, comma, the mean of the data set, comma, the standard deviation of the data set, close your bracket, hit enter, and the calculator will tell you, it'll tell us that 95.44% of the data in a data set that has a mean of 1.4, standard deviation of 0.3 would be between 0.8 and 2. And keep in mind, the calculator actually has a more accurate answer than that original graph. This graph here that's in the textbook, these percentages are rounded, so this 95% is a rounded value. It's actually, what the calculator told us, 95.44% of the data, or 0.45, sorry if I round that properly. 95.45. Good. Okay. Another example. What percent of cacti are between 1 and 1.5 meters tall? So once again, our mean is in the middle. Standard deviation is 0.3. And what percent are between 1 and 1.5 meters tall? So I want the, so 1 is roughly here. Oops, that doesn't look good. And 1.5 is roughly here. I want the percent of cacti that are between those two heights, so I want the area between those two x values. So here is x equals 1. Here is x equals 1.5. I want the area between those two. I just have to use the calculator function normalcdf. Tell it my left and right boundaries, which are 1 and 1.5, and then tell it the mean and standard deviation of the data set, which is 1.4 and 0.3. The calculator will then tell me what percent of the data in the data set are between 1 and 1.5. If the data set has a mean of 1.4, standard deviation of 0.3, and I would get, so your second bars, normalcdf, 1, 1.5, 1.4, 0.3. Close the bracket, enter. It would tell me 53.93% of the cacti. 53.93% of the cacti would have a height between 1, which was right here, and 1.5 meters. Number 4, what percent of cacti are less than 1.38 meters tall? So here's our 1.4, 1.7, 2, 2.3, 1.1, 0.8, 0.5. What percent of cacti have a height less than 1.38 meters tall? So 1.38 is roughly here on our graph. I want the area to the left of that. There's a couple ways we can do this. If we want to use our calculator again, all we have to do is tell the calculator the left and right boundary. Because this graph continues forever, our left boundary is going to be negative infinity, and our right boundary is going to be x equals 1.38. And also keep in mind the mean of our data set is 1.4 and standard deviation is 0.3, so we just have to type in normalcdf. Our left boundary is negative infinity because this graph will go on forever. Negative infinity, how you write down your calculator is you do negative 1 e99. That says negative 1 times 10 to the 99, which gives you a very large negative number. So your negative 1 e99 is our left boundary. Our right boundary is 1.38. The mean is 1.4 for our data set, and the standard deviation is 0.3. If we do this, the calculator will tell us the percent of data in the data set that are between negative infinity and 1.38. Okay, so if we do that, second vars normalcdf between negative infinity, so you do negative 1, and then e is above the comma, then 99, comma 1.38 is our right boundary, comma 1.4 is the mean, comma 0.3 is the standard deviation. Close the bracket, enter. Tell us 47.34% of the cacti. 47.34. Let me see if I can just bring this here for you so you can see it. 47.34% of the cacti would have a height less than 1.38 meters tall. Okay. Another way we could have done this question, if you don't want to use the calculator function, you could also use z-scores. So let me see if I can I'll get rid of all this. This is the only one I'll use z-scores for you. So what we could have done, we could have translated this piece of data onto the standard normal distribution graph. Remember, standard normal distribution graph is has a mean of 0 and a standard deviation of 1. So to translate that piece of data onto this graph, we would first have to calculate the z-score for x equals 1.38. And the formula for z-score, so it's z-score of 1.38. You do that piece of data minus the mean divided by the standard deviation. So you do 1.38 minus 1.4 divided by 0.3. And if you do that, 1.38 minus 1.4, and then divide that answer by 0.3, get negative 0.07. Let me just pause this. My TV just turned on. I can't pause it. Okay, hold on one sec. See if the Penguins can get to their game a little bit here in the second period and establish some of that zone time. Brandon Sutter's line on the ice with Ryan. Okay, I'm back. Penguins game just came back on, so I'll just hurry up and finish this lesson. So we calculated the z-score that corresponded to x equals 1.38. Now what we need to do is transfer that onto our standard normal distribution graph. So negative 0.07 would be very close to 0 here, just slightly below 0. Z equals negative 0.07. That would be right here. Whoops. And once again, we want the area to the left. To find the area to the left, all you have to do is look at your z-score table. Do I have one up already? Yes, I do. Find negative 0.07. So negative 0.0 go across to 7. So 0, 1, 2, 3, 4, 5, 6, 7. There it is here. Make sure I lined it up right. Yep. So that would tell us 47.21%. And I think that's close to what we had before. What did we have before? Let me just double check. Distribution, normal CDF, between negative infinity, 1.38, 0.4, 0.7. We had 48.86 when we did it using the calculator. And we have 47.21 when we use z-score. So when we use the z-score, 47.21 when we use the z-score. Notice it's going to be a slightly different answer, and that's once again because this z-score that we calculated was actually negative 0.0666666, and we had to round it. So when you do a rounding, when you have to round your answer, you're going to end up with a percentage that is only approximate because we had to round our z-score, so it's going to be close to the actual answer. The actual answer was when we used the calculator, we got 48 point some odd percent, okay, 48.86%. So it's up to you which method you use. Calculator is more accurate and it's more time efficient, so I recommend that, but if you want to use z-scores, that's good as well. Let's do another example. What percent of cacti are likely more than 1 meter tall? So more than 1 meter. Okay, so this one's slightly different because normally we do less than. More than 1 meter, keep in mind, here's our mean. Standard deviation is 0.3, 1.1, 0.8, 0.5. Okay, we want more than 1 meter. 1 meter would be, 1 meter would be approximately right here. We want more than 1 meter, so now we want the area to the right. So our left boundary is now x equals 1. Our right boundary, because this graph goes on forever, is going to be x equals infinity. And how we write infinity is going to be 1, positive 1, E99. So we're going to do normal CDF. We want the area to the right of 1. So our left boundary is going to be 1. Our right boundary is infinity, so 1 E99, 1 times 10 to the 99. The mean of our data set is 1.4. Standard deviation is 0.3. Let's type that in the calculator. Get it restarted here. Second vars, go down to normalcdf, boundaries 1, and then 1 E99 to use infinity. Oops. 99, comma, the mean of the set of data, which is 1.4, comma, the standard deviation, which is 0.3. Close our bracket, hit enter, and it'll tell us 90.88%, 90.88% of cacti will have a height of 1 meter or greater. Okay, because the area to the right of 1 is 0.9088. Last example, we're going to work backwards for this example, kind of. So for this example, I'm now going to tell you the percent I want, and you're going to find the value for x. Okay, so normally I give you the value for x, and I ask you like what percent is left, or what percent is to the right, or what percent is between these two values of x. Now I'm going to give you the percentage to the left of the value of x, and you have to find the value of x. So find the 90th percentile of cactus height. So what that means is find which value of x, where along here is the area to the left going to equal 0.9. So it's going to be somewhere, I'm looking for the area of this to equal 0.9. What is the value of x? Okay, so I now know the percentile. I know the area to the left. So if you want, you can go to your z-score table and look for where you might find 0.9. So look all throughout here, find a percent that's 0.9. Because remember, on the z-score table, it always gives you the area to the left. Okay, so find 0.9 on this table here. 0.9 is, this is the closest to 0.9 we can get right here, and that is 1.28. Okay, so a z-score of 1.28 would give you the 90th percentile. So keep in mind, if z-scores have to do with the standard normal distribution graph, which has a mean of 0, standard deviation of 1. We found out that a z-score of 1.28, so which is right here roughly, so this is z equals 1.28. For a set of data that is normally distributed, 90% of that data would have a z-score equal to or less than 1.28. But now that we have the z-score, I need to now figure out the actual, what is the x value at this point, because we want to know the height of the cacti. Okay, so we're going to have to use our z-score formula. So z-score equals x minus x bar divided by standard deviation. We know the z-score. Z-score is 1.28. We don't know the x value. We do know the mean of the set of data is 1.4, and the standard deviation of the set of data is 0.3. So now all you have to do is go ahead and solve for x. So do 1.28 times 0.3, and then add your 1.4, and you'll get a cactus height of 1.784 meters. So a cactus of 1.784 meters would be in the 90th percentile. That meaning 90% of the cacti will have a height of this or less. Let me show you another way how you could have done this question. You can actually do this type of question using a calculator function on your TI-83 as well. So when you know the percentile and you're looking for the x value, we're kind of going backwards. So you're going to use the function inverse normal. You're going to tell your calculator what percentile you're looking for. So looking for the 90th percentile, so that's an area of 0.9 to the left. You're then going to type in the mean and the standard deviation, and that's it. And then that'll tell you what x value corresponds to that percentile for a data set that has a mean of 1.4, standard deviation of 0.3. So let's go ahead and do that. I'll bring up the calculator, and we'll go back to second vars to bring up distributions, go down to inverse normal, type in the percentile, so 0.9, type in the mean, 1.4, and then the standard deviation, 0.3. Hit enter, and it tells you the same value that we found using our z-score table, 1.784. Okay, so a cactus of 1.784 meters tall. Here's x equals 1.784 would be in the 90th percentile because the area to the left of that would be 0.9, which means 90% of the Diomedes that have a z-score, or sorry, have a height of this or less. And I think that's it. There's an assignment that goes with this chapter that has a lot to do with normal distributions, so if you want, you could try that out as well. Let me know if you have any questions.